Morning Auto 2, we're going to be doing a little more electrical testing, showing you some equipment, showing you how it can be used. Here's a test light, and I've got digital multimeter, or DMM. I've got some scan tools, etc. This is a 2008 Chevy Silverado, and I'm going to show you how we're going to use this this test light. And one of the simple ways we can, the battery's over here, your safety glasses on, and the negative side of the battery is actually behind this bracket, but I couldn't reach it. And what you're going to notice is I'm going to take this test light, touch the positive side, and you should be able to see immediately that it lights up. Okay, now you can see it behind my hand. So this is a great way of obviously finding power, and just pull off the negative side. But if I want to come over here on this side of the car where this under hood fuse panel is, and I'll set this camera down so you can see it. Here's the fuse panel. Here you can see the picture of the fuse, and then it says there's a lock here, and it's got an arrow, so I can pull this guy off and get him out of there. And then I can see, I'm coming a little closer, I can see that fuse and relay center, and I'll come down in a little bit closer. And as you look at this, you'll notice that there's a couple of large Bosch style relays, 1, 2, 3. Then there's 1, 2, 3, 4, 5, 6 smaller ones. And then there's some of these really small ones. These are relays as well. And by the way, as you look at these relays, the ones with the copper edges, that one and that one, are the switch circuit, and the ones with the silvery tips are the control circuit. Okay, so I'll put that back in. So we've got 3 different size relays in this box, and we've got some box type fuses, and we have some small mini fuses. So there's a lot of relays and fuses in there. And on the back of our cover, we've got a legend here so we can kind of know what things are. So as I look around in there, I look for a critical one. Okay, so there's looks like we got a fuel pump relay right next to a park lamp relay. So this looks like it's the fuel pump relay. So that's kind of nice to identify if we're going to do some testing, etc. But really all I wanted to do here is just show you how to use some test equipment. So I'm going to go ahead and go onto this, see if I can put the ground for this meter, this digital multimeter, on this bolt right here on the side of the alternator, and it may not stay there. We'll see if it does. And I'm going to come in and just poke around on some fuses, and of course I lost my ground already. Okay, well, we're off to a rip-roaring start here this morning. Okay, here's a stud that I should be able to grab onto better. Okay, so now one of the things I can use my test light for, and looks like I don't have ground there. So let me see if I can get a better spot. Let's try there. There we go. Okay, so you can see that I'm getting the test light to light up. I'll hold it like this. It's a little easier for you to see it light up. Okay, you can see that I'm touching the prongs on the fuse there and there. This one's not powered up. So some fuses are not powered up, right, until you turn the key on. But I can really quickly check the fuse. If there's power on both prongs, I know the fuse is not burned. So a test light's really great for finding power and testing to see if a fuse is good. Now these type of fuses, I have to pull them out with a pair of pliers in order to test them. But a test light is just really fabulous for finding power right away. So that red lead there on the alternator should be power, and I'll poke it in. Sure enough, I can find power there right now, or I just poke right through that insulation. So you can see that a test light is just a fabulous way of really quickly finding power, and we like to use them a lot. And I'm a big fan of them because they're just a really quick tool at locating power. So what I'm going to do next is I'm going to take the digital multimeter right here, and I'm going to pull these banana plug ends off. These are alligator leads, but this type of connector is what we call a banana plug. Tilt this down a little bit. Call these banana plugs. So they're really nice because they just plug in and out. And I'm going to go ahead and put some. Well, those are alligator leads too, so that wouldn't make any sense, does it? Where's my tips? Okay, there's the tip. And I'll put a tip on there. And let me see if I have another tip to put on there. And we'll find one here in just a moment. I'll just put this on the hot side. So when I buy these meters, these digital multimeters made by, I get them from AES Wave, and they are an ES automotive meter, which is Electronic Specialties. I buy the meters, and then I go out and buy Fluke leads. Fluke is a really high quality electrical test company. And I always buy Fluke leads because the Fluke leads make the meter just so much better. They're way sharper for poking through insulation. They have really good alligator clips and banana plugs. But a couple things about automotive digital multimeters. So first, whenever you use one, you want to make sure to push the leads in, because as you're going like this, they tend to lift out, and then you'll wonder why the meter's not working. And so always make sure they're pushed in. Secondly, the black lead here always goes to common. On the screen here it says CON for common, and that's another name for ground, if you will, or just return path to the meter. So I'm going to push that guy in. This red one says volt, ohms, hertz, percentage RPM, capacitance, milliseconds, dwell, centigrade, and Fahrenheit. So we can measure temperature. Over here on this side, this is a 20 amp ammeter reading spot and a 400 milliamp ammeter reading spot. This 20 amp has a 20 amp fuse in it. It says 20 amps for 30 seconds max, every 15 minutes fused. So we don't want to put this meter over here unless we're very intentionally trying to measure current and we know what we're doing, so that we don't blow the fuse in the meter. It's not that it's expensive, it's just that it's a pain to change. So most of the time we're using on 90% of the time we're using this meter is a voltmeter. Maybe 5% of the time, or maybe 8% of the time is an ohm meter, and 2 or 3% of the time is a ammeter. We can also measure things like RPM, what's called dwell, millisecond pulse for injectors, hertz, which is a frequency for a sensor output. But volts and ohms are really going to be what we're going to use a lot. So we go here to the V setting for volts. And the blue, it says DC or AC. So we can push this DC, AC button. Now it's configured for AC volts. Push it again, it's for DC volts. So yeah, push it to AC. Push this into your, get another lead on this end. Push these into your wall socket, and you can measure your 110 volt or 120 volt and see what you have. So what I'm going to do is put this back to DC. I'm going to use the alligator clips nice to be able to put on the ground and then probe around for electricity. So I'm going to go ahead and leave the meter here so you guys can see the screen. And I'm going to take the black ground, and can I reach it to the battery? Not quite. So I'm going to come just back over here. And you can still see if you can read it there. Let's try putting it down here. Maybe that's a better way of reading it. Sorry, trying to get it to stand up, and it's not standing up so well. So there we go. So I'll go ahead and clip this to the negative lead. And when I do, and then I touch this to the positive lead, you can see on the screen I'm getting 12.31 volts. Okay, I take it off, and I just get some certain amount of millivolts, stray voltages in the air. Push it back on, I'm getting 12.31 volts. So I'm going to grab the camera and bring it over here and see if I can do a little bit closer and a better job with this. So here's my cord. Here's my voltmeter. And I'll put it right there and see if you can. And I accidentally hit AC, so there's DC. Okay. We're having technical difficulties with our meter, aren't we? Okay. All right, so I've got it once again once again, I got it on the positive side. And once again, I've got the meter wrapped around my camera. There we go. Finally, I don't. So we're reading, here we go, 12.32 volts on the battery right there. Okay, now, if I take the negative side, and that's called resting voltage, if I take and swap the leads, I'm going to get a negative. You can see under the DC, negative 12.32 or 31 volts. Doesn't hurt the meter, just reads negative. So I'll put it back to where the alligator's over there on the negative clamp, and I'll touch here on the positive clamp. And once again, I'm back to positive 12.32 volts DC. And it's on an auto ranging scale, meaning it'll range up to however many hundreds of volts that it's set to go. And usually these are good, like this one says it's up to 600 volts. So this will actually go up to 600 volts. It'll measure. Okay, so we never want to put it on the ohms setting and then attach it to a battery or something like that, because we immediately pop the fuse. So we call this, right now, we say this battery is at rest. We don't have anything turned on. Now, in reality, there are some circuits on, like the clock is pulling power out of this, the computer memories are pulling power out of this, maybe stereo preset memories drawing power out of this. So very, very little, but in essence, otherwise we have everything off. So if we want to do a true open circuit voltage test, we would have to disconnect these cables from the battery and then just measure the battery itself. But right now it does have some electrical output coming out of it, even though we've got the car off and we don't have anything intentionally on. We're reading 12.32 resting volts. And if we wanted to go a true open circuit voltage, we'd have to disable all the connections from the battery, and then we might get closer to 12.6 volts. So here's what I'm going to do now. I'm going to change my end, and I'm going to pull off this lead here like that. And I'm going to grab one of these other alligator clips. Doesn't matter what color. The color is immaterial. So I'm taking this out, plug this in. I'm going to go ahead and put this on the positive terminal. And we're going to hold this by the meter. And where it's sitting right here, I can start the car like that. And you're going to see the voltage probably momentarily drop down to something like 10 or 11 volts during cranking. And then when it starts, it should go up to roughly 14 volts. So let's give it a shot. This will be what we call our running voltage. So we've got 14.8786 volts. That's our charging system voltage. So our resting voltage was 12.3 or so, and our charging system voltage or running voltage is 14.89 volts on this 2008 Chevy Silverado with a 4.8 liter V8, complete with low oil pressure and lots of lifter knock that gets worse as the engine oil heats up. By the way, this takes 5W30 oil, as you can see on the cap there, and I'm going to go ahead and put 2050 oil in it and see if it quiets down enough so that I can drive it, set the monitors, get it smogged, and then we can register it in the Auto Club name and then repair it. But anyways, our running voltage is 14.83 to 89 volts, so we know the alternator's charging. Let me shut the car off. One thing I want you to notice, and by the way, look at the surface charge. The car's off and it's reading 13.25 volts and dropping. So that means that the battery's been excited by the alternator and it's starting to calm down, just like you going for a run and your pulse takes time to calm down. So it's calming down. That battery's a living environment with two dissimilar metals in an acid solution. So notice that with the black lead to the negative and the red lead to the positive, the voltmeter is attached to the battery or to any power source in parallel. This is a parallel circuit, not in series, meaning series would be if we took this cable off and attached this lead to the cable and attached this lead to the post. Then it would be in series. So we always use a voltmeter in parallel. We'll talk about ammeter and checking amperage later. If we were to try and use the ohm meter to do a continuity test or to measure resistance in the circuit, we have to make sure the circuit's off, because this has a 9-volt battery that's doing a voltage drop across whatever device you're checking. And if you're checking in a live circuit, the voltage will cause this thing to read inaccurately. It won't hurt the meter, but it will read inaccurately. So we always use the meter when the circuit's off. By the way, this does have an auto power off feature, so if you leave the meter on, it'll shut off after 5 minutes, so we don't wear the battery out. Okay, next I'm going to take a simple scan tool. This is a $30 scan tool, and show you how we can take this inside and we can actually check resting and running voltage, which gives us a way of another way of testing electrical systems and seeing what the computer is seeing. So we'll go under the dash here, and there's our 16-pin trapezoid diagnostic link connector that every car since 1996, and the thing is powering up right now. Scan tool is, but we've got to turn the ignition on. So there's our dash warning icons are lit up. For the scan tool to be able to read, we've got to turn this on. So now we're going to go ahead and push enter. And right now what it's doing is it is talking to the computer. And it says 0 codes found, monitors not applicable is 4. And we're going to go down here and look at the monitors. Go to IM readiness, and I'll go to engine. And it says since DTC is cleared, I'll say yes. And it says, well, look at this. All the monitors are set. So this truck will actually pass smog right now, which I had no idea that they're already set. So this thing will pass smog right now as we speak, and there's no codes present. So I'll just go back here. Go to previous menu and previous menu. Okay, go here. Let's go to codes, read codes, and it says no code stored in the module. Press any key to continue. So if the check engine light's off, there's no codes present, all the monitors are set, this truck will pass smog. I want to show you another scan tool. That's a cheap scan tool. Let me get another expensive one. When I plug in this scan tool, so here's the modus. This is our $5,700 Snap-on modus. Turn this guy on. And what this guy allows us to do, and I'll plug the diagnostic link connector, which you'll notice the green button comes on when it gets power, which is really nice because you can tell, see the green button there. So the nice thing is you can tell that the DLC is powering up because there is a fuse that powers that guy up. I want you to just see in our little discussion of electrical test equipment, I want you to see the difference between a $30 scan tool and a $5,700 scan tool. Well, this thing can do a lot more, and we're going to go here. And by the way, I do have the dash warning icons up, so the ignition's on. And I turn it on, and it says current vehicle is this. And I say, okay. So it already read it. It automatically extracted what vehicle it was on its own. And I can do a number of things. Engine, transmission, anti-lock brakes. I can look at oil specs and resets, tire and wheel service, trailer brake control module, airbag, passenger presence system. Hey, tire pressure monitor. This thing has a tire pressure monitor system. I checked it out with the Snap-on TPMS3. It's got 3 bad sensors on it, but let's go there and take a look. And it says, let's go display codes. And it says right front low tire pressure sensor. And it says right rear low tire pressure sensor, and I think it's also got a left rear, but it's only showing me 2 codes. So a CO755, those are chassis codes. The 0 means that it's not a manufacturer specific code, but it's a chassis code 755, 765. It's telling me we got 2 sensors that are bad. And I'll go back here for a moment if I can. There we go. I can clear codes, functional test, troubleshooter, etc. I'm going to go back again. And so look at all these modules that I can look at. Park assist module, keyless entry, theft deterrent. These are all computers. Auxiliary body control, radio, body control module, door switch, driver, fuel pump. There's HVAC, rollover sensor. I can look at a lot of different stuff. Instrument cluster, seat module, electronic suspension control, vehicle communication interface. I can look at all kinds of stuff and go back to home here, whereas this one can only look at codes on the engine. This thing can code a chip in a new key. I get a key cut. This thing will code the chip, and on some cars it'll actually program the fob as well. So a really, really important tool. It's got a troubleshooter in it. It can actually graph the output of sensors. Let's go back to scanner. And let's go back to, now it's asking me to load in the vehicle for some reason. Let's hit Chevrolet, which is right there. And we'll go 2008 there. Loading database. And let's go automatic ID. And it should read the vehicle. And it did, 08 Silverado. Now I'm going to go to engine. It's a touchscreen if you didn't notice. I'm going to go to data display. And it gives me different types of data display, misfire data, etc. I'm going to go to engine data, and I'm going to try and see if we can read resting voltage. So look, it's got things listed here. We'll bump down here, and we'll look for voltage. Okay. So far, we're just seeing other things here. So let's look for... Now that last one had ignition voltage, but we're looking for charging system voltage or battery voltage. Still looking. Engine oil level, engine oil pressure, vehicle speed. Okay, so I don't see... let's go back here. Let's go back one. And let's go to, let me see what other data it shows here. Ignition data, accessory electrical theft data. Let's see what we get here. Okay, just trying to see if we can, where we find a PID, which is a parameter identification that shows voltage. And I haven't seen it yet. Maybe I missed it. Maybe I went right by it, and you guys are saying, wow, let me kill, you're really a loser. Okay, battery voltage. There it is. That's a hybrid battery. Well, it says, oh, sorry, AC disengaged battery voltage. Okay, let's keep going. Okay, scrolling down here. So a lot of stuff you can get lost in. 5-volt reference signal. Still looking at where our voltage is. So this is a classic one where you go, you know, sometimes, let me go here again. Back here. Let's go engine. And let's go to data display. And let's go to sensor data. And let's see what we get on sensor data. Let's see if we can get a voltage reading here somewhere. These are all O2 sensors. Those are O2 sensors, injectors, fuel trim. Okay, I know I'm starting to bore you. So it's interesting that it's a little more challenging on this big one for us to find voltage. So I know that I'm quite sure that if I go to the small scan tool, and I'll do that, I'm going to go to the small scan tool just because of how quickly it should show me battery voltage, and I should have done that when I had it plugged in the first time, but I didn't. You can say, Mr. L, wow, you're losing it. And I say, I know, I understand. So I powered off the big guy. Let's load this little guy. And this one reads really fast. So we'll go here, we'll go to live data engine, and here comes our PIDs, which is parameter identification. So it's reading all kinds of information. And then right away, if I scroll down, see if I get battery voltage. Okay. Yeah, a little surprise. Okay, here we go. Vehicle power voltage. I'm reading 11.704 volts that you can see there. Now I'm going to go ahead and start the car. And then now you can see immediately that that's going to, can you see that there on the screen? Going to 14.5 volts. So now you can see the voltage that the scan tool is reading. Okay, just want to give you a little introduction there to scan tools. This one's very powerful. This one doesn't do much, but boy, it does probably 95% of what you want, and it does it really, really fast. And again, we got that TPMS monitor light flashing because we got a couple of sensors that are out. Okay, I'm going to shut this off. I'm going to unplug the scan tool. We'll come back. And that's what I wanted to show you. Some little bit into electrical test equipment, digital multimeters, test light, scan tools, things that can give us testing equipment to be able to look at things electrically in a car. All right, there we go.